We just got done looking at how we can do all kinds of different conversions within stoichiometry, and now we're going to look at a couple of problems that focus on solutions, so using liters and moles and a balanced equation to do some calculations. So we're going to see a couple different types of those. Here's the first one, and I've got a little bit of molar mass help over here on the side, and then just a reminder that these are some of the tools that we can use. Molarity is going to be our new one in these problems. So we can take any molarity that we see and write it as moles per liter. So let's go ahead and read the problem and get organized and then convert. So a solution of lead nitrate, we're looking at this balanced equation here, is added to a solution of potassium chromate and a yellow precipitate forms. So ultimately, who cares? There's no numbers there. How many grams of PbCr4, so this is what I'm looking for here, how many grams can be produced if 25.5 mils of 0.222 molarity PbNO3, so this is what I'm looking at here, reacts with excess, so that means more than enough of this potassium chromate. So if you can kind of picture back to this reaction, we can work our way in on one side and work our way out on the other. And that's what we're going to do here. We're going to work our way in at the lead nitrate and then work our way out at the lead chromate. So I really only have two numbers that are given to me, 25.5 mils and then this molarity. And it's a good idea to rewrite your molarity right off the bat as a moles per liter. And don't forget what chemical it is, because we do have different chemicals in play here, right? So I want to keep track that that's the lead nitrate. So you can do this in a lot of different ways. I'm going to string it together as one long conversion, but if you want to break it into pieces and do it differently, totally fine, okay? So I'm going to start here with the 25.5 milliliters. Don't start with your conversion, start with your number that's not a conversion. And this is lead nitrate. And I know that I'm trying to get 2 grams of lead chromate down here. So I'm going to leave myself that little note that this is where I'm headed. I have this molarity, and the molarity is going to help me get to moles, which is going to help me use my mole ratios. So I need to work my way to molarity, and that means I need to get to liters. So 1 mil is the same as 10 to the negative 3 liters, all of lead nitrate. And then liters come to the denominator, moles on top. Now I can get from my mils into moles of my lead nitrate. And this is where this value is going to come in. So I've got my moles over my liters. And I'm going to plug that number in, 0.222 moles, always per 1 liter when I have molarity. Now I'm in lead nitrate, I need to get to lead chromate. So let's bring this same unit down here, lead nitrate. And once I'm in moles, that's where I can use my coefficients here, 1, 1, 1, 2, and switch chemicals to the lead chromate. So I check out the lead nitrate, coefficient is 1. I check out the lead chromate, coefficient is 1. And then lastly, I need to bring my moles of lead chromate down here, and I'm working towards the grams. I gave you that mass over here, so lead chromate molar mass is 323.19 grams per 1 mole. So look what happened here. I've got mils canceling, liters canceling, moles canceling, moles canceling, and I'm left with the grams of the lead nitrate. If you calculate that out and pay attention to your 3 sig figs here at the beginning, you've got 1.83 grams of lead chromate. All right, and it was a relatively small amount of solution, so it makes sense that I came out with 1.83 grams, not 183 grams, or it's super tiny amount, 0.0001 grams or something like that. So that was taking a volume and working my way over to a solid. Next problem, we'll look at something more like a acid-base problem, where we have a similar problem with a molarity in the middle, but it'll be slightly different spin on it.